Okay. Probability. So, a set is a well-defined collection of distinct objects. Each object in the set is called an element. I've tried to bold the critical words. So each object in the set is called an element of the set. And the set is often denoted by writing elements in braces, or these fun little swirly things. I just try to draw, and sometimes they look really bad, and then those little swirly things. Do you need help drawing the swirly things? You start in, come out, give it a point, and come back in. That's silly that I showed you that, and you might be laughing that I showed you that, so I'm not really laughing right now, but it's funny, sometimes I watch people draw this, and then they always apologize, because they always look like this. There you go. It kind of looks like a face, yeah. So this is called set notation. So if I tell you that, if I wanted you to write the set of numbers on a dice, you would write this. 1, 2, 3, 4, 5. Assuming it's a 6-sided dice, that's what the set would look like. So each side of the dice would be an element in the set, and I would list the set with brackets. Now we can title the sets with A, B's, C's, D's. I'll call it the D's because it's dice, whatever. So that's what a set would look like. You're on your phone, please. The set with no elements in it is called the empty set. If you remember it, because you wouldn't put anything in those little brackets. Called the empty set. There's 2 ways to write the empty set. You could do it by that little 0 with a slash through it. That's the symbol for the empty set. Or you could write it like this. A set notation. Nothing in the inside. The set of all elements under consideration is called the universal set. So the universal set is every single possibility. So if I'm talking about integers, the universal set would be every single integer. A subset, so a smaller group, would be like the even integers. So it's part of the bigger set, but it's not every single thing. It's a subset. Identifying the number of elements in the set is important for calculating probabilities. The notation this, n of a, is asking for the number of elements in the set. You won't use this very often, but sometimes you'll see it in just a minute. Okay, any questions so far? Kind of give you a basis for where we're going. All right, keep it moving. Example 1. Use set notation to identify each set described in the table and identify the number of elements in each set. So, set A is the set of prime numbers less than 10. So what would be in set A? What's the first number? 1 technically not a prime number. 2. 2 is the first. 2, and then 3, and then 5, and then anything else? So the number of elements in that set is 4. Set B is the set of all even natural numbers less than 10. What's a natural number? Basically a whole number that's, basically a whole number. So, 2, 4, 6, 8. Why did I not include 10? It's gotta be less than 10. Good, and the number of elements in that set is 4 again. Set C is the set of all natural numbers less than 10 that are multiples of 4. So, a natural number, does that include 0? Let's say no. The whole numbers include 0, the natural numbers don't. So we don't include 0. What's the very first one? 4 is the first multiple of 4, and then 8. Good. So the number of elements in that set, 2. The universal set is all natural numbers less than 10. So in this set, it would be 1, 2, 3, 4, 5, 9, and then add 9 on each one of them. So each of these sets, A, B, C, are a subset of the universal set, because each one of those is a member of the bigger set. The 4 and the 8 are both in here. The 2, 4, 6, 8 are all in here, and so on. Okay, let's give you some notation. Set C is a subset of set B. If every element in C is also an element in B. The notation for that is set C is a subset of set B. Okay, so the notation for that is like a sideways C. So this is the subset notation. It means let me just clarify, hold on. Should I get rid of that paper packet? Just want to make sure I told you that right. Strike that, reverse it. The B and the C need to go backwards. Sorry. It looks a lot more to see than I want it to. Let's do like a sideways view. Okay, C is a subset of B. So C is kind of like, you can think of it as like a less than almost, but not quite. C is a subset of B because everything that's in C is also in B. So on this one, is B a subset of U? Is everything in here in here? Is C a subset of B? Everything in here is also in here. Is B a subset of C? No, because everything in here is not also in here. Does that make sense? So if I were to draw the Venn diagram or the picture of that, let's just have this whole box be the universal set. So if this was B, this would be C. Everything in C is also in B. It's a smaller set. An example of that is maybe if set B was even numbers and set C was multiples of 4. Is C part of B? Are the multiples of 4 also even? Yeah, it's a smaller grouping of the one above it. Does that sort of make sense what a subset is? Okay. The intersection, the notation for intersection is this. An intersection of sets A and B is the set of all elements that are in O, this is critical, A, and B. The notation for that is this, and an upside down U. Again, notation is probably the hardest part of today. If I were to draw a Venn diagram of that, if this was A and this was B, the intersection would just be this overlap, the numbers that are in both of those. Okay, if B was the set of all odd numbers less than 10 and A is the set of primes less than 10, what would be the intersection? What kind of numbers are in both of those groups? Well, the odds are 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. Just kidding. 1, 3, 5, 7, 9, right? So which of those 1, 3, 5, 7, 9 are primes? 1's not. 3 is. 5 and 7. This would be the intersection of those two groups, because these are the numbers that fit both criteria. Is that okay? This one has to fit both. Keyword, intersection, both. Any ideas how we can remember that?
Because it's the hardest part. So we just need to come up with an idea of how we can remember that intersection is both. You're in driver's ed, or you have been recently, or you will be very soon. If you're standing in the middle of an intersection, what street are you technically on? If you're right in the middle of it, you're in both streets. Is that a way we could remember? I don't know. Any other ideas? Okay, let's keep going. I don't even remember it, but you need to figure out how to remember it.
The union of sets A and B is the set of all elements that are in A or B. So this is an either. Either or, it doesn't matter which. The notation for that is the little u. You can remember that because the u looks like the u right there. The Venn diagram for that, if this is A and this is B, it doesn't really matter, it just has to be in one or the other. If we use the same group from above, if we're using the same example from above, we are going to list all of the odd numbers less than 10, and we'll list all primes less than 10. So what are the odd numbers less than 10? 1, 3, 5, 7, 9. And then did we miss any prime numbers in that list? Those are all of the odd numbers less than 10, which satisfies option or set B. Now if we look at set A, we've only missed the 2. So that's what this set would be. This is the union. We've taken the two sets and we've like married them together. What yours is now mine, what is mine is now yours. We are together as one. It's a marriage of two groups. Does it have to be in order? No, unless you have like perfectionist issues and you want to put that 2 in here. It doesn't have to be in order. When I read the answers to you, will I tell you them in order? Yes. So when I guess I don't read the answers anymore, right? So when you're looking at the answer key, they probably will be in order. You need to make sure the 2 goes where it's at. Any questions so far? This is a lot of vocabulary, but do you feel okay with it? It's a different kind of math. Some of you look bored. Are you with me? Okay. And the last one is the complement. The complement of set A is the set of, the complement of set A is the set of all elements. I'm pretty sure that sentence isn't finished. Set of all elements not in set A. So in this case, you're going to need to know what the universal set is. So the Venn diagram on this one, if this is set A, then all of the elements that are not in that group are all of the numbers in the universal set outside of the group. The notation, oh, I just missed the box. The notation for that has a set with a little c up top. Kind of like an exponent, that's what it looks like. And then, an example, we need to define what the universal set is. If the universal set is this heap of numbers less than 10, and if A is all of the even numbers, then A complement would be all of the what? Odd numbers. And then these are still less than 10, right? So the elements in A would be 2, 4, 6, 8, but in the complement it would be 1, 3, 5, 7, 9, right? Because it's everything else. So come back to this chart if you're wondering what this symbol means, what this symbol means. Don't ask me what this symbol means, come to the chart and figure it out. And then if you can't figure it out, then ask me. Because everything you need to know, hopefully, is in this little book. Okay, so example 2. Given that set A are the even integers less than or equal to 20, set
B is the integers from 0 to 50 that are multiples of 5. C are the prime integers from 0 to 20. And D are the odd integers less than or equal to 10. Oh, that's tricky. It means negative positive, but that means it's going to go further. Instead of integers, let's assume this as, because technically this set right here, technically this set right here includes negative numbers, and I don't want to. So let's change all of these to whole numbers. That one's okay. Alright, technically that's what it should be. Alright, the even whole numbers less than or equal to 20. So, that set would include what? Technically 0 is even, because if you say 0 divided by 2 is there a remainder. And 0 is a whole number, so 0 then what? 2, 4, 6. Why do you think it's important to list out the elements in your set? Yeah. You want to be able to see what you're looking at. So this is set. This is set A. Oh, right here. Oh, yeah. Thank you. 2, 4, 6, 10, 12, 14, 15, 18, 20. And how many are in set A? What's the... How many elements are in set A? 11. Because of the 0, it's 11. If the 0 isn't there, it would be 10. Okay, what about B? The whole numbers from 0 to 50 that are multiples of 5. Is 0 a multiple of 5? Yeah, there's 0 of them, but it's technically a multiple of 5. So we're going to have to list 0. 0, then what? 5, then? From 0 to 50, yep. If it would have just said less than 50, I wouldn't have, but from 0 to 50. How many elements are in that set? Okay, what about set C, the prime integers from 0 to 20? What prime numbers are between 0 and 20? So 0 is not prime, 1 is not prime, 2, then 3, then, okay. 11, the next one, then 13, not 15, but 17, good. Those are the prime numbers less than 20. Oh, 19. Sorry, this one. Good. Okay, how many of those are there? Okay, I don't know if we're going to need this or not, but we're going with it. And then the last one, C. The odd whole numbers less than or equal to 10. 1 through 5, 7, 8. And there are 5 of those. Okay, let's take all of those steps and answer some questions. I want to know what does this mean? Union, right? I remember that because it's a U. I want to know what the union is between A and B. Union means what? Both. I want to know it's in both. So what I do here, and write small because these are kind of big. So the union of A or B is, I look at A, 0, 2, 4, and I have to list all of the numbers in A. But then I also have to list the numbers in B that aren't in A. So in A, I've got 0, 2, 4, and then I notice that 5 is in B, right? So let's throw that 5 in from the B group. Or you can just list them and then just list them. And then 6, 8, now 10 is in both groups. Do I have to list it twice? No. You can just list it the one time. And keep going. 12, 14, then what? Jumping from the B group is 15. both. Now we've exhausted the A group. We keep going with the B group. It comes up to 20, 25, 30, 35, 40, 45. Way to go, teacher, for choosing a lot in sorry. That's a lot. So that would be the union. Those are the numbers that are in both. We will need that when we start calculating probabilities. Okay, what about part F? What does that little upside down union mean? Intersection. Intersection is the and. So if I put a line through here, it looks like an A, right? That's how I can remember it's an and. And means it has to be in what? Both. Like you're in both streets, right? So this is both B and C. Look at those two. What numbers are in both? 5 is. What else? That's it. This is multiple of 5. These are 10 numbers. That's it. Oh. Say S. Is that an intersection or is that a union? That one is an intersection. Good. It has to be in what? Both. So looking at A and B, what numbers are in both? None. So this is called the, do you remember? Empty set. There's two ways to write it. One is like this. One is like this. Either one. Okay, what about part G? G is the body. It's the union. This means what? The union is the either or. So looking at B and D, these two groups, it has to be an either or. So start with the 0. This is the low one, right? 0. And then come down here, 1. And then 3. They both have a 5. 7, 9, come down here. Kind of nice. At this point, we've exhausted D, right? So we just keep going up with the rest of the B group. What's that? All right, we've looked through several of these now. What questions do you have? Okay. No, I think really good. All right, what about G? Why don't you try that one on your own? G and H. There's one of each. There's one of them is a union, one of them is an intersection, as I can say. Hard for radio association. What is what you have to do with your number? Okay, C, union D. What is in that set? Are we looking for both or are we looking for either or? Either or. So, looking at D, that one has the 1. This one has a 2. They both have a 3. They both have a 5. They both have a 7. That one has a 9. And then we can carry on with this one, right? 11, 13, 17, 19. Yes? Any questions? Raise your hand if you got that. I'll give you 10 points. No. How about H? This one means the and, right? A little H through that, and. It means it has to be in both groups. So if you're looking at A and C, what numbers are in both groups? 2. Anything else? No, that's it. 2 is the only even number that is also prime. Every other even number doesn't work. 2 is even and prime. All right, now let's talk about how you calculate the probability. Probability is just the study of chance. So what's the likelihood that something is going to happen? An experiment is an activity that can be used to calculate probabilities, and each possible result of the experiment is called an outcome. So rolling a dice would be the experiment. So if you wanted to roll a dice, that's the experiment. If you rolled a 1, that would be the outcome. If you rolled a 5, that would be the outcome. The probability that you rolled a 5 is the chance that you would have to roll a 5. So probability is measured by how likely an event is to occur when all outcomes of an experiment are equally likely. For example, the probability that events would occur in the sample space S. So sample space we haven't talked about yet. A sample space is kind of like the universal set, sort of. It's all possible outcomes. Oh no, it's right here. Just kidding. A set of outcomes is known as the sample space. So rolling the dice, the sample space is 1, 2, 3, 4, 5, 6. This is a lot lighter. Ooh, that would be, depends on if you want to do like the 2 different numbers, if you want like the sum. If you were just looking at rolling 2 dice and looking at the numbers, the sample space would be 1, 1, 1, 2, 1, 3, does that make sense? Different possibilities. And then there would be 36.
So would you write it like that, or would you write it out?
If you were asked to list the sample space, it would probably write it something like that. Maybe put it in like parentheses. Ooh, we will get there in just a minute. So if I'm trying to calculate the probability, I just have to take the number of outcomes for the event and the number of outcomes for the sample space. So for example, if it was rolling the 2 dice, that we were finding the sum, and I wanted to find the probability that the sum was 12 of 2 dice, how many times could I get a sum of 12? My only choice is if I rolled 2 what? 6s. And there's no other way to get it, right? So there's one way to get 12, so that would be a 1, out of how many possibilities are there? Actually, there's 36 with the 2 different dice. So if you were to list all of the dice in like a grid, like a 6x6 grid, right, I could get 2 1s, I could get 2s and 3 and on. There would be 36 possibilities. We'll talk more about this in a minute. I promise it's not hard. Yes? Basically, and if there were 3 dice, you would cube it. And okay, so the numbers 1 through 30 are placed in a hat to determine the order in which students will give a class presentation. Every student draws a number, and then that's your order. Event A is being one of the first 10 students to give their report. So let's stop. If you are in set A, what numbers would you have drawn? 1 through 10. Event B is picking a multiple of 6 as your presentation number. So if you were drawn in event B, what number of paper do you have? Do you have a question or are we going to answer? Okay, go ahead. I was wondering that as I was writing them all out. I don't mind if you put 1 through 10 as long as you know how many are in that. It's fine. Okay, set B is what? 6, 12, 18, 24, and 30. You could have drawn one of those 4 if you were in set B. And why do we have this right I don't remember what I was thinking when I did that. I don't think I read. Okay, what's the probability of A happening? Really quick, how many, we do want this though, how many numbers are in my sample space? How many numbers are in the bag? 30. So the denominator on all of my probabilities will be 30. Okay, so what's the probability of A happening? How many are there in set A? 10 out of a possible what? 30. Now you could reduce that fraction, make it 1/3. You could also change that fraction to a decimal, which would be what? 0.33. You could also change that decimal to a percentage, which would be what? 33. We'll stop 33 seconds. Periodically throughout your assignment and throughout the notes, it will tell you how it wants the final answer. Assume that if it doesn't tell you anything, that the 1/3 is probably the best way. Okay? Alright. What about the intersection? So let's first list what the intersection is, maybe down a little bit lower. What numbers are in, is this both or is this or? Both. So we need to figure out what numbers are in both. Only 6? Okay. So what's the probability that you're in both of these groups? How many are there? 1 out of how many possible? 30. What about the union of those two groups? How many are in either or? Well, there's 10 in this group, right? 10. Do I count this one? No. 11, 12, 13, 14. Do you agree with me that there are 14 numbers in either of those two? Or in both of those? You have to be careful with the word both. They're not in both. Do you agree that there's 14 numbers in either of those two groups? It isn't this way. If you smush them together. If it helps you to list them, then list them. I can't count the 6 twice. There's not 2 6s in the bag, right? So count those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of what? 30, which is the same as 7 out of 16. Okay, yes. Go for it. Not necessarily. It would have had to tell us what C was. Okay. All right. The probability of A complement. What do you remember what A complement means? This means everything else is not in A. Good. So if A is 1 through 10, then A complement is going to be 11 through 30, right? How many numbers are there between 11 and 30? 20. So the probability of A complement would be 20 out of 30, which is the same as 2/3. Notice something really quick. The probability of A and the probability of A complement, if we added those together, what would it be? 100%. They're getting, which makes sense, right? If I had probability of somebody scoring on the test is this group, and then everybody else would be this group, right? I would add them together, we would be the entire class. Okay. So A and A complement, all you have to be 1. If you add those together, you get 1. 30 out of 30. 100% greater. Okay? Probability of B complement. So what can we do here? We know how many items are in B. 5, right? If there are 5 items in B, that means how many items are not in B? 25? So to find B complement, the number in B complement, I can take 30, which is my total, subtract 5, so that's how many are in B, and I would get the 25. Sorry, I've kind of made down here my scratch paper. Is that okay? This is truly scratch paper. It's not like showing my work, it's just scratch. I need you guys to ask questions if you have them. We haven't really taught this way all year. And it's more important for you to ask them now than to sit confused. Or you could fall asleep. There it is. Okay. What about this one? What's the probability of A? What does that mean? And or? That's an or, so either or. What's the probability of A or A complement? That's what we just answered, right? This is the group in A, this is everything else, so this would be 100%. So 30 out of 30. 1. Technically, I would say that's probably the best answer, 1. Let's keep going. All right, so this next example has to deal with GPA and how many classes we skip, which hopefully it never happens in this class. If you did it in class. Wow. Wow, there's no way to say that. I'm looking amazing. Yeah, I'm just kidding. Great. I did make goodness those sounds in my a student has a GPA between 2 and 3. So, we are just looking at the students with a GPA between 2 and 3. Where does that go? Right here. Sorry, you're in the front row. Not so bad. It's looking at that column right there. I'm looking for, it doesn't really matter if they skipped class or not. I just want to find the probability that a student has a GPA between 2 and 3. Well, I need to find how many total people there are between 2 and 3. What's the total in that grouping? 475. Out of what? The possible total, which is 1,000 students that they looked at. Now, do you remember on your calculator how to change that into a reduced fraction? If you have a graphing calculator, just like in 475 divided by 1,000, you get a decimal, you do math and enter, fraction is reduced, you do nothing. If you have just a scientific calculator, if you type this in using the ABC button and push enter, I believe it reduces for you. 1940. No, that's a lot of people that have a GPA between 2 and 3. Oh. Now this is called a marginal probability because we're only looking at one category. This is a two-way table where we have two variables. We've got a GPA. We'll talk more about two-way variables next time. But you have a GPA and you have people skipping school. So there's two variables you're looking at. And I'm only looking at one column, so it's called a marginal probability. Okay. Part B, what is the probability that a student has a GPA under 2.0 and has skipped many classes? So this is an intersection or is this a union? And we've got to be in both categories, right? Who is in both categories? So again, let's look at what groups we're looking at. What is the probability that a student has a GPA under 2.0? So that's this column, right? And they've skipped a lot of classes. That would be the 80. You agree? They're in both categories. So this is 80 out of 1,000. So this 8 out of 100 is just 450 is just 30 sometimes. What is the probability that a student has a GPA under 2.0? Again, that's this column, right? Or has skipped many classes. This is an or, which means I am looking at both of those, because that's the under 2.0, or has skipped many classes, or this category. So how are you going to figure that out? You add the two totals. You could look at the totals to help you. However, there's a problem in that. Can you think about the problem? Erin? So you can't count the 80 twice. Right. In both of those totals, so it might be easier to count the 110, because that counts all of those, and then tack the 175 on it. Is that fair?
Does that add all of the red dots together? Or could you just say 80, 25, 5, or 75, add those together, get something, and then just use that number? Yeah, that might be easier. It doesn't matter. I really don't care. But how many are in all 4 of those red categories? Say again? 285 out of what? A little 8 in there. Out of 1,000, because that's how many people there were total. 57 out of 200. Good. Questions on that one?
Do you see the difference on how you would use the table between the and the or? Okay.
The and, it has to be in both places. It's literally the overlap. The or is either or.
What is the probability that a student's GPA is under 2.0 and
They did not skip many classes.
so on your own, go for it. All right, this is an and, it's an intersection. So under 2.0 is this column, right?
They did not skip many classes. Which one of those? 175 out of? Equals?
Okay. I think we're on our last bit, and then you can work on your homework, which I haven't given you yet, otherwise you probably would have started. If A is a set of 5, 6, 7, and B is a set of 6, 8, well, actually, on your own, when you answer A through F, try them out.
True or false? This is not an always, sometimes, never. If it's sometimes, then it's false. True or false?
Thumbs up, thumbs down. Do we like probability? Boring. Not taking you to Vegas.
Oh, I'm fine.
All right, let's finish this off. Yeah. If A is 5, 6, 7, and B is 6, 8, 10, 12, then the union of them is 5, 6, 7, 8, 10, 12. True or false? True. Good. That's frozen. Hold on, I can do this. Freeze. If the probability, if set P, which is not probability, is A, B, C, and Q is B, C, D, so you could have other things rather than numbers, phones, please. The intersection of them will be B and C. True? B and C are in both groups, so it would be true. Unions of 2 sets is the set of elements which are common. Is that a union? Is that a union or is that an intersection? The one they have in common, that is false. Good. Instead of union, let's fix it. This is supposed to be what word? Good. If we change that to intersection, then I would say it's true. If A is 1, 3, 5, 7, and B is 3, 4, 5, 6, then the, what's that? And the intersection is 1, 3, 4, 5, 6, 7. True or false? False. Good. What would the intersection be? Fix it. Intersection is 1 in both groups? No, it's 3. Yes. It's 5. Yes, and that is it. The intersection is only the overlap. Did I miss one? Oh, but B is not. That is not here. So we're good. All right, E, if P is A, B, C, D, E, and Q is A, E, I, O, U, then P union Q is A, B, C, D, E, I, O, U.
Yeah.
I was trying to think which of the I, O, U. Intersection of 2 sets is a set of elements that are both common. Both the sets. We fixed that one up here. I would say that's true. Good. All right. Thanks for watching. Come to class. stay in school.